Hello all, this is Shruti Punagu, a student of University of New Haven, doing my master's in cybersecurity and networking. I'm so happy to share this video with all of you where I have learned a lot of things developing this project called Cloud-Based PE Malware Detection API as a part of my course. I've done this under the guidance of my professor Wahid. uh, so let me just give you a brief idea about what this is, what I have done to achieve this project, complete this project, and what all the things that should you should take care that you don't run into a problem doing this project. So the abstract of this project is that we all have been facing a lot of issues with malware attacks, ransomware attacks, where you will have an executable file and it has a malicious software that will ruin all your data or logs up your data for a ransomware attack. So this project is solely made to let users use it, upload their executable files and understand if it's a malware or a benign file so that they'll be careful and not be a victim of any such attacks. All right, it has three major parts. I'll be explaining you in the project overview. Let me be quick so that it will not be boring. All right, so we have three major tasks. The first task is about training the machine learning model using Malcolm architecture. The task two is about deployment of that model on API. And the task three is about creating a PE client using Gradio where you will have a web application and a good user interface. All right. I know I'm being fast, but you'll just understand the project as it goes. All right. So, coming to the technical approach, I've used PyTorch 2.x and Python 3.x to develop this Malcolm architecture, and I've used the dataset from Ember 2017 v2. Also, I've used Ember 2018 for some parts. I'll be sharing all the files that I've used in the Git repository. You can have a look. That's under the description of this video. And I'll also be sharing this PDF for your references. All right. So when it comes for training strategy, I have decided to take the training as 80% and the validation for 20%, where the other 10% would be for testing. And we made sure we're using, because I'm using Google Colab, it's not really that easy to run it on your local system. So I've used Google Colab with T4 GPU acceleration. All right. Then when it comes to task two, I have used AWS SageMaker, where I had a $50 budget to use for. So I have created an inference file for the model that I've created, and I have deployed it onto an API that I created on AWS SageMaker. I'll briefly go through it once we reach that point. When it comes to task three, here I've developed a web app using Gradio where you will have a GUI that can take PE files and give you the output. All right. So this is my Git repository. I'll be sharing the link below the video. Also, I'll just show you the approximate tree of this. Yeah. As I told in training, we have building a static malware detector and a malconvert training architecture. All right. When it comes to part two, deployment, you have inference and the model that I have developed using Malcolm training. And there is deployment IPYNB file that I executed in AWS SageMaker. And I have a requirements text where you can see the dependencies of the project. Now in part three, we have a PE client IPYNB file, which generates the link that directs you to the particular website. All right. So let me quickly start explaining the code for the first part. Right. So this is the first part, that is the training the dataset with Malcolm architecture, right? Before jumping directly into the code, make sure you're going through these steps. Okay. Firstly, mount the Google Drive on your collab so that you will not lose the data every time you refresh it. Secondly, change the runtime to T4 GPU because it's a very heavy work on the CPU. So I would recommend you to go to T4 GPU. Then third thing is make sure you are creating this um, folder in your Google Drive before entering into the code. All right. Now, after doing all this, we should get the pre-processed training datasets, training and test datasets from the respective places. You can also take the data and process it by yourself, but it's really time-taking process. So this is something easier to, go through the project. All right. I am downloading all the files that I need, training and test datasets. All right. Here I am downloading metadata.csv file as well. All right. Now that I have downloaded all that, I'm making sure I'm mounting the drive on my Google Colab using this snippet. After I mount it successfully, I'm making sure I'm copying all the files that I have downloaded from the for the data sets. All right. So that I'll not lose the data every time. Since we are using Ember data set, I'm making sure that I'm cloning the repository and installing the GitHub repository of Ember. All right. And yeah, this is where we are vectorizing the features of the data that we have. All right, the Ember data that we have downloaded, the test and train data, we are making sure we have the vectorized features of them. All right. Now that we have the vectorized features, I'm making sure I don't have any rows without any labels. If there are any rows without labels, I'm making sure I delete it so that we'll not have any garbage values in our data. All right. Now that you have done, your data is clean. You have a clean vectorized data. We are making a .h5 files so that it's easier to store large numerical data sets, because you could see that the dimensions are very large, and when you have this such kind of data sets, it's better you store it in a h5 extension. All right. Once you are saving it, make sure you're changing the path to your drive so that you will not lose it the next time you come back to the code. All right. So when it comes to training the Malcolm architecture, we have three basic things. First thing is building that architecture. Second one is training it, and third one is testing it. All right. Now this part of the code trains the Malcolm architecture. I have given the class and I have given the technicalities that it need. All right. It's successfully done. Now that it's done, I'm using min-max scaler, and I'm normalizing the data that I have so that it's not more complicated. All right. Once normalizing is done and we get the tensors, we get the PyTorch tensors of the data that we have. Right. This is how you get hold of the tensors. Once you are done with the building of the data, now building of the architecture, now you make sure you double check that you have converted to T4 GPU so that you will not have your Google Colab crashed in between. All right. Now that you have the runtime changed. This is the training of data. So here you will have almost 15 epochs, and you will have the batch size of 64. All right. They process in batches and give you a trained data, trained model. All right. From this, I see the input tensor. Once you tensorize the data, you can see the size, shape of the input tensors. All right. Yeah. Once you are done it, we filter it, limit it, and scale it to our up to 1,000 samples, because if you're having heavy data, it's not that easy to process on your GPU. All right. Now that we have done training the data, we are going training the model. We are going to task three, where you test if it's working in a proper way or not. So I could say I'm not really having a good accuracy or precision for now, but we can work better to make it, more precise. All right. After I get to the technicalities. I make sure I'm printing the confusion matrix that I've got from my data from my model. Once you're done with the confusion matrix, I am trying to create a dummy executable file and give it as an input so that I can see if it's working or not, if my model is working or not. Seen that it had generated the raw byte values, then it turned it into a tensor, and now it predicted it to be a malware file. Uh, so if you want more information about the model, you can go through this, data that I have given in the repository. All right. All right. So as I told, this is my AWS console. I have opened a Jupyter notebook on my AWS console. So I've basically created a notebook instance and I've created a Jupyter notebook. All right. When I open this, yeah. Uh, I'll better explain this on Visual Studio so that I have comments on it and you'll understand it better. All right, this is the deployment of the model that I've trained previously using Malcolm architecture, right? You can make it into a zip file. So I'm basically copying these files onto my Jupyter notebook. Then I'm handling model interference on AWS SageMaker by loading a trained model, processing input features, making predictions, and returning a JSON format file. All right. So this is the inference file that I was talking about, which helps you, to put the trained model into it and get the expected output from it. All right. So once I run this, the inference.py that you have seen in my here, this inference.py will be it will be filled basically with the code that I've given. Then here I am compressing it into a tar file so that you will be able to use it in the deployment. I'm giving the requirements.txt. These are the dependencies that you'll be using for the deployment. Here are the essential libraries that you'll be using. This is the place where you get interesting. All right. This is creating a S3 bucket on the Amazon SageMaker. I'll be showing you it to it. Yeah. This is the page of S3 buckets. So you can see the bucket is being created once I run the code. Once this bucket will be loaded with the model file that I am currently using. All right. Now this is retrieving the Docker image using the Python, right? Now here you will be getting the default bucket from the SageMaker and you'll be loading the model tar as I told you. All right. After loading the data, now you'll create the model using your Docker image that you are getting here. The image that you are retrieving here, you will be creating a model using it. After creating a model, you will get a model name and you will get a model ARN where the model is being deployed, created basically. Okay. After that, you will be creating an endpoint configuration. Actually, this is a big code snippet which creates an endpoint configuration. But because I was not able to, I didn't have access to create it through code, I managed to create it manually where yeah, this is the endpoint configuration that I've created manually instead of using the code. All right. So once I've created it manually, I've given this endpoint name into the code here so that it will be easier for the code to understand and pick it up from there. All right. After creating the configuration, now we are creating an endpoint. All right. Once this is created, you are getting then endpoint ARN as the output. Make sure you are having this name saved with you. You will be needing it later. All right. Now we are monitoring the status of creation of endpoint so that we are making sure it is coming in service. Okay. Once you are monitoring it, you will be getting until creating until it is in service and gives the data of it. I can show you the endpoint that's being created here. So I've ran the code twice, so you could see two endpoints here. You could use either of it because you have both in service. You don't have any failed endpoints for now. All right. After this, you'll be invoking the SageMaker endpoint to test whether it's working properly or not. All right. About the third part of the project, when it comes to client, yeah, I'll just explain the code here so that it will be easier. All right. So I'm installing Gradio as we need it to create the web page. Then Boto 3 as usual and a PE file because we are handling PE files basically. All right. After this code is all about the Gradio code that allows users to upload the PE file for malware detection. It extracts the features from PE files and it gives the prediction whether it's a malware or a benign. The result, whether it's a malware or benign, it is given in the interface. It efficiently combines file processing, feature extraction, and UI malware detection. All right. This is the code for it. You can get hold of it once you look at my directory. All right. I'll just run it for you. All right. So here you could see that It has run. All right. Let me open it in a. Okay. Let's say it's a calculator file. I'm just uploading it. Oh, sorry. I'm just uploading it here. Submit. It's benign. Before that, make sure you're clearing it off. All right. And now you're putting the sample on it. Yeah, it says malware. All right. Yeah, this is all about the application that I've been talking about, and you will be having the uh, link below in the description. Make sure you're checking it out and understand it thoroughly before you jump into it. Thank you so much.